Hi guys and welcome to the fun and excitement otherwise known as Matrices. Yes, this is a continuation of the Methods 3 and 4 course over here in Australia, delivered by a Brit who's Australian and trying to market this to all sorts of the world. And that's not weird, nothing will be. It's really good seeing you here. Thank you so much for joining me. I'm MaffsGuru, otherwise known as my real name, Darren, and I am delighted to see you here. Now, if you can do me the honour, if you haven't already done so, over there, yes, there's an arrow saying something along the lines of click to show me you're watching. Subscribing to my YouTube channel actually lets me know that people are genuinely watching these videos and finding use from them. Leave me a comment below. Let me know how you think of the videos, or you know, just say hi. It would be awesome if you could do that, and I will respond. I'm quite good at that. Otherwise, let's get moving on. Now, matrices. I've actually said a lot about matrices in previous videos because I keep talking about being able to use them to solve simultaneous equations. The only thing is I haven't actually taught you how to solve simultaneous equations. Well, the good news is that's coming in another video. Yay! Not this video, because I suppose first things first, we need to recap what matrices are. And we've done a little bit of this in Methods 1 and 2 and in previous courses, but by the end of this video, hopefully you'll know how to express something in matrix notation, how to add, subtract, multiply by a scalar, and how to multiply matrices together. And believe it or not, multiplying two matrices together is the one thing that tends to trick people left, right, and center. It shouldn't. Don't worry about it. It's actually useful. And you've got to be able to use the cas to do all of the above. Now, I said just there, you know, you can use matrices in so many different things. Please don't think of this as a standalone lesson. What you learn now will be useful to simultaneous equations, but it's also going to be useful for transformations. And transformations is a massive section coming up after the next few videos. So it's not something to learn and forget, it's something to learn and I suppose understand. But, all right, look, I say there's not much to know here. There's just lots of terms and keywords. So the first thing is a matrix. Believe it or not, when you put your credit card or debit card in a hole in the wall to get money, your credit card is nothing more than just a massive matrix. It is a huge array of numbers organized into rows and columns that sort of identify you as you. It keeps your information. It helps sort of protect your PIN number. And when you put your ATM card in the bank, then believe it or not, some very special math happens and it compares what's on your matrix with what's their expected matrix. And if it all works together and you put the right PIN number in, then it'll actually let you have money. If it lets you have money without any of that correct, let me know where that cash point is, because I wouldn't mind some money, that is, not cash points, because that would be weird. So a matrix is nothing more than an array of numbers. Now, the way we talk about arrays of numbers is we write them in square brackets, and you can probably argue there that those square brackets aren't necessarily square, or in fact brackets, but they are meant to be. And that's literally a matrix. That's what we call a 2 by 2 matrix, and I'll come back on that in just a moment. There's other matrices, which is like 1, 2. You can write them as 2, 1. Oh, no, that bracket is way too big. You can write, you can have 3 by 3 matrices. What do I mean by 3 by 3? 1, 2, 3, 3, 2, 1, 1, 0, 1. For example, they are matrices. You can even have matrices with zeros in them. And that's, funny enough, called the zero matrix. Why are you asking, would I have a zero in a matrix? I don't know. It's part of the course. It's weird. Let's move on. But basically, matrices are just drawn with those square brackets and numbers inside them, organized into rows and columns. Now, naming matrices, again, is something that's relatively simple. And the way we tend to name a matrix is by giving it a capital letter. And in a textbook, it will be a bold capital letter. So we may say, for example, that A is defined as 1, 2, 3, 4. And B is defined as 4, 3, 2, and 1. Now, the way that's useful to us is because we can then sort of simplify things and say, well, can you please work out the sum of A and B, or A plus B? It makes life a lot easier than trying to write those matrices out left, right, and center. So whenever you see a capital letter, generally in bold in the textbook, it means that that is the matrix, which will have been defined previous in the question. Now, entries. And I swear in further maths they're called elements, but I've definitely got elements in my head from somewhere. Maybe it's general maths. I don't know. But each individual number inside that matrix is called an element. 1, 2, 3, 4. So you would argue there are 4 elements in that matrix. Let's call it matrix X, so that it actually has a name. And there we go. And each element is defined by a row and a column. Now, if you're thinking, what do you mean? Think about Excel. So when we think about Excel, and yes, I'm talking about Microsoft Excel, you'll know that you've got letters here, A, B, C, D, and 1, 2, 3, and 4. Exactly the same idea. This cell here is referenced as A1. Why? Well, in that situation, they do column followed by row. In matrices, we do row followed by column, but more of that's coming on in a moment. But each of those numbers is effectively an entry or an element. Now, dimensions are important, in fact, critically important. And I think I alluded to it a moment ago. If I had the matrix 1, 2, 3, 4, and you can notice this is my standalone or go-to matrix, and let's call it Z in this case, I can describe that as a 2 by 2 matrix. 2 by 2, or 2 with an X and a 2. Many times I see those in brackets. The brackets come useful in just a moment. But what on earth does it mean by 2 by 2? We reference dimensions as rows and then columns. So the first one is always row and the second one is always the column. And the way I remember this is that when I wake up in the morning, I'm fairly RC. Yeah, no. So rows followed by columns. Moving on. And how is that going to be important to me? Well, believe it or not, rows and columns play a significant part in helping us multiply matrices together and whether things are defined. So this one here, if I had that 1, 2, that would be defined as how many rows? 2 by 1 column. Likewise, you can have 1 by 1s. They can be all sorts of different sizes. But start using this notation or this idea of a dimension. I've already said they're rows and columns. Very, very important, so I don't really need to say much more. Now, one of the things that tends to throw people is this notation here of A, I, J. Now, what that's referencing is a specific element or entry in a matrix, in this situation probably labeled A. So if I had A, let's go to my standard 1, 2, let's mix things up and put 4 and 3. Oof, pushing the boat out there. Then what I now know is that A, 1, 1, is referencing the first number in the first row, first column. So it's referencing the number that's in the first row and the first column. So there is my first row. There is my first column. And so in that situation, A11 would be 1. And I suppose in the same way, A21 would be the second row, first column, which would be 4. Now, bizarrely, they can actually give you rules to all of this to say that Aij is equal to I plus j. Now, lots of people look at that and go, I have no idea what you're talking about. But in that situation, if I had this matrix here, because I've got my first row and my first column, that number there would be 2 because 1 plus 1. Here, this value here, I've got my first row, second column, so you'd add those two together. Likewise, the next one would be second row, first column, that would be 3, and that would be 4. So sometimes they can throw this sort of stuff in, more possibly in further maths to try and sort of trick you. But, you know, it's useful to know how elements are. Now, adding, subtracting, and multiplying by a scalar. So let's deal with adding matrices first. So easy. If I had the matrix A was equal to, let's just go 1, 2, 3, 4. And we have matrix B is equal to 5, 6, 0. That's a 2 and 0. Let's just throw that one in there. You can only add matrices that have the same size or the same dimension. So in this situation here, if I wanted to do A plus B, I can do it. And the way I do that is 1, 2, 3, 4 plus 5, 6, 2, and 0. Now, when you add matrices together, you add like elements together. So you add 1, 1, and 1, 1, and 1, 2, and 2, 1, and 1, 2, and 1, 2, and so, what do I mean? Basically, in this situation, I take the 1 and the 5, and I add them together to give 6. I take the 2 and the 6, I add them together to give 8. The 3 and the 2, because they're in the same place in each of the matrices, 3 and 2 is 5, and 0 and 4 would give me 4. And ladies and gentlemen, I have added together two matrices. Not particularly difficult now. And if I wanted to do B minus A, well, in this situation, I'd put B first, and then I'm going to subtract A, which is 1, 2, 3, and 4. And that gives me, my computer's having a bit of a lag, so likewise, 5 minus 1 gives me 4, 6 minus 2 gives me 4, 2 minus 3 gives me negative 1, and yes, you can have negative numbers, it's no reason, and 0 minus 4 gives me negative 4. Awesome! So adding and subtracting, really useful, helpful, but again, you can only do it when the matrices are the same size. So you notice in each of these, they were both 2 by 2 matrices. I can't take away a 2 by 1 from a 2 by 2. This doesn't make any sense. Now, multiplying by a scalar. A scalar is just one number, and the way we can do that is think of something like 3a. Now that's basically taking that's basically taking matrix A and multiplying it by 3. But what does it mean? Well, if I have 3 lots of 1, 2, 3, and 4, what it's actually asked me to do is multiply every single item inside that matrix by 3. So I get 3, 6, 9, and 12. Really not very much else I can do. I mean, we can piggyback these together by saying 3a plus 2b, so I can do 3 lots of a plus 2 lots of b and add them all together. It doesn't get any more complicated than that. We can have fractions outside of these as scalars. It goes on. Now, to multiply by a scalar, you're simply multiplying each element or entry by the number outside the matrix. Yes, I've done that. Thank you very much. I left some space for some more working up, but don't need it. Now, multiplication of matrices. I'm going to start really easy because it's a process, it's a method. So firstly, do you remember FOIL? And that was x plus 2 multiplied by x minus 3. Now, what's this got to do with the price of fish? Absolutely nothing. But it is going to help us realize that there was a process to this and there's a process to matrices. So if you remember the process of FOIL, it was first times first, then first times the outside, insides multiplied together, and the last two multiplied together. Yes, so first, outside, inside, and last. I from the UK, I used to think first times first, first times second. So first times first, first times second, second times first, second times second. I actually think this is going to be more useful. Because when we multiply matrices together, we have to make sure we multiply rows by columns. And you do first row by first column, first row by second column by first, and second by second. You see what I did there? 1, 1, 1, 2, 2, 1, 2, 2. Now the rules, and I've deliberately written these like these, are firstly, you can only multiply matrices when the number of columns in the first matches the number of rows in the second. The size of the resulting matrix is the number of rows in the first matrix by the number of and you multiply here. Wow. Believe it or not, there's a much, much easier way than doing this. So I'm going to multiply together A, which is 1, 2, 3, 4, and B, which is, let's choose something like 2, 0, 3, 2, just to make life a little bit easier. So the first thing we're going to do is the order of the multiplication is important. All right, I know for normal numbers 2 times 3 is the same as 3 times 2, but A times B and B times A could be different. Hold that thought. So I'm going to work out A times B. Now the way we do that is we write A, 1, 2, 3, 4, and then beside it we write B, which is 2, 0, 3, and 2. The first thing I have to do is work out whether I can actually even multiply these together. And the way I do that is, this is rules 1 and 2, is I actually write down underneath that that's a 2 by 2, and that's a 2 by 2. Now the great thing is that if these two numbers here, the middle two numbers match, then we can multiply those matrices out and life is good. And what part 2 is sort of saying to you is that the resultant matrix would be these values on the outside. So it would be a 2 by 2. So knowing this, I can now scaffold this as a square brackets, roughly 2 by 2. Now, let's go back to this 1, 1, 1, 2, 2, 1, 2, 2. First row multiplies by the first column. So the first row multiplies by the first column. That's going to give me my value, the first value in the top left-hand corner. Now when I say first row times first column, what I actually mean is you take each of the pairs of numbers. So as I travel across and as I travel down, there are pairs of numbers. The 1 here and the 2 pair up, and the 2 and the 3 pair up. Now by pairing up I mean multiply together. So that first number is 1 times 2. So the first number times the first number plus the second times the second. So 1 times 2 is 2. 2 times 3 is 6. Add those together, gives me 8. Another one. So I've done 1, 1, 1, 1, 1. Now I'm going to do 1, 2. First row, second column. So I'm sticking with this first row, but now I'm doing this second column and I'm pairing the numbers up. The 1 and the 0 and the 2 and the 2 pair up. So the 1 and the 0 multiply them gives me 0, and 2 times 2 gives me 4. Add them together gives me 4. Now I've done 1, 1 and 1, 2. I'm going to go 2, 1. Second row, first column. So we're now on the second row. and back to this first column. So now I've got the 3 and the 2 join, and the 4 and the 3 join. So the 3 and the 2, the 4 and the 3. So 3 times 2 is 6, 4 times 3 is 12. Add those together, gives me 18. And finally, we're now doing 2, 2, second row, second column. 3 times 4, 0 and 2. So 3 times 0 is 0, 4 times 2 is 8. And ladies and gentlemen, I have multiplied my two matrices together. So what about if I had matrix C now as 1, 3? Can I do A times C? Well, here is A, 1, 2, 3, 4. And here is C, which is 1 and 3. So first thing you've got to do is try and check. That's a 2 by 2. How many rows does this have? 2. How many columns? It has 1. Are these middle two things the same? They are. So I can multiply them together and my output will be a 2 by 1. So there is my 2 by 1. And again, I now do first row by first column. In fact, there's only one column. So first row by first column, 1 times 1 is 1, 2 times 3 is 6. Add the two together, gives me 7. And now second row times first column. 3 times 1 is 3, 4 times 3 is 12. Add the two together, gives me 15. And there we go. Now, just carrying on, just in this space here, could I do C times A? Well, that's 1, 3. A we decided was 1, 2, 3, 4. Let's just check. This was a 2 row by 1 column. This was a 2 by 2. Those two there are not the same. And so, ladies and gentlemen, we say that that is undefined. So if a question then says to you, are the following things defined as in A times B or 2A plus C or whatever else, then what they're asking you to do is check to see whether they can multiply together. Now, somewhere on the internet, I was very lucky to find this thing here, which gives an example of multiplying matrices together. And that is ready for download from the PDF notes, which can be found on MaffsGuru.com. Okay, so if you click onto MaffsGuru.com, you can sort of download all the PDFs and all the notes from this particular exercise. So that's there just to try and explain it again if you didn't understand it. Please go back, play the video again if you need to. Multiply matrices is actually quite useful, and matrices itself. Finally, before I finish this video, we need to look at an identity matrix and square matrix. Well, the first thing is a square matrix is literally that. It is a matrix that is square. So you can have a 2 by 2. What did I say there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 by 3. They're all examples of square matrices. And in fact, that is a 1 by 1 matrix, and it is still square. The identity matrix is actually really important because what you may have noticed is throughout this video, I didn't talk about dividing matrices. You cannot divide matrices. You can't do A divided by B. What we have to do is we use a bit of a trick, and that's coming way, way, way later. But the point of it is an identity matrix helps this division work. And an identity matrix is basically a matrix that has 1, 0, 0, 1. That's the first one. Yeah, I can have 1, 0, 0, 0, 1, 0, 0, 0, 1. And I can have a 1 in there as a 1 by 1. Again, an identity matrix is a square matrix. It has to be square. And what you notice is you have 1s running through it diagonally. So it'll be 1, 1, 1, 1, and it'll keep going. All the rest of the elements are 0. Now you're going to say, what's the point of the identity matrix? When I multiply anything by the identity matrix, I actually get the matrix I first started with, believe it or not. So if I have, let's just do 1, 2, 3, 4 again. And we multiply it by 1, 0, 0, 1. But we already know that's going to be defined because it's a 2 by 2 multiplied by a 2 by 2. So now I do my first row times my first column. So 1 times 1, that goes there. 1 times 0 plus 2 times 1 goes 2. 3 times 1, 4 times 0 gives me 3. 3 times 0, 4 times 1, it gives me 4. And lo and behold, I've ended up back with my original matrix. And you're going to say, but why will I do that? Very good question. And it's all answered when we do division and something called inverse matrices, which is a whole new ballpark. Well, ladies and gentlemen, I am done. This was a recap of matrices. Thank you very much for watching. Again, if you haven't already done so, can you squidge that little button there and subscribe and shout out that I'm here. The little guy is trying to sort of help people. And otherwise, there's a video over there loading for you to watch. Look, it's been good. Thank you so much for taking the time to watch this far. I look forward to seeing you next time. MaffsGuru, out.